We are going to be continuing our look into Chapter 4 with this video. In the last one, we looked at some notation to get us off the ground. And in this one, we're going to actually start looking at some of those common statistical measures. The first type, of which there are three in this chapter, that we're going to look at is the measures of central location. Before I introduce any of these, let's just talk about what these measures are, what we're trying to get out of it. All right, so let's imagine that all of the possible outcomes for our variable lie on an infinite spectrum here. Right? So all of anything that we're going to be using these measures for are going to be quantitative. That is the thrust of this chapter, is that we're looking at the quantitative stuff now. So it could, in theory, right, especially when we don't know what the variable is yet, we just know that it's going to has to do with numbers. That data could take any point along our interval here, right? So anywhere along this infinite interval, right, from positive infinity to negative infinity. So what we're trying to do with our measures of central location is we're saying, well, hey, we've got, a bunch of data. Actually, let me change this. Let's go with, these aren't really great colors. Let's go with magenta. All right, so my data, if we kind of think about our dot plots, this would be somewhat similar, though not doing quite as good of a job. All right, let's say that this is, we've got some data here. So we say, well, something that might be interesting is kind of where does most of that data center around, right? So central location, so where is kind of the heart of my data along this infinite number line? The one very common type of measure of central location, and it's what the focus of this video is going to be, is the mean. Right, or should I say means? Right, so we're going to look at three different types of means. All right, we're going to look at the arithmetic mean, we're going to look at the weighted mean, and we're going to look at the trimmed mean. All right, so again, all three of these are means, and they are measures of central location. All right, so most of the time when we are talking about means, we don't really specify what type of mean we are talking about. And that is because most of the time we are talking about an arithmetic mean. All right, so an arithmetic mean, this is what we think of most of the time when we hear a mean, right? So an average, a mean, this is that classical calculation for an average. All right, so we're going to just go ahead and write down the formulas, and then we'll talk through them a little bit, although I'm sure we're all at least somewhat familiar with an average. But this is where something we mentioned in the last video comes into play. Right? We have different ways of, in some cases, simply writing the formula, different way of writing the formula out. If we have a parameter versus a statistic, as is the case here between a population mean, so the parameter, and the sample mean, which is a statistic. Here it's really just notation. We're going to see in some later videos that that's not always the case. Sometimes a population parameter is calculated differently than a sample statistic, and we have to watch out for that. All right, but for a population mean, the symbol we use is mu. Right? It's the Greek symbol mu, and it looks kind of like a U with two sideburns. That one of them, that's not a sideburn. whatever it is, right? Maybe some braids, right? And somebody cut one off, right? This looks a little lopsided, right? And our population mean, or mu, is equal to the sum of xi over n. All right, so a lot of this we should be familiar with. Mu might be new for some of us. This point we should be pretty familiar with that sum of xi, that's just x1 plus x2, on and on. And I'm kind of running out of room, so I'll just let that go. All right, and then capital N, this is something that I meant to put in that other video, but I forgot. Capital N is the population size. All right, so how many members are in the population? All right, and this matters because we should, and so the implication being that I'm not going to leave this up for a real long time, right? That our summation symbol here, right, would actually look like this, all right? So I equals n to capital N, right? Because we would need in this scenario to have a piece of data for every member of the population, all right? Because to calculate your population parameter, you have to have all the data from the population. All right, so that is our population mean. Before we do any example, let's look at the sample mean. All right, so the sample mean is very similar. Right, this is one of the few exceptions, right, to the statistics just being represented by just a letter, right? Because as we can see up here, this is x bar, right? And that is how we would pronounce that. So x bar, most of the time, these sample statistics, they are just a regular old letter. S is one that we will see later on. P, so on and so forth. Sample means a little unique in that it's not just an x, it is x bar, but we use x quite a lot, so you have to excuse us on that one, I think. All right, so again, x bar. Again, we've got that sum of xi here. We have n lowercase, which is our sample size. So how many observations did we get for our sample? So it's not the entire population. We didn't get information on every member of the population, but we got data on some of the members. All right, but again, we're just going to add up all the data we got, right, all the way to that last one, and then divide by n. It's an average, right, relatively simple. Right, so let's go ahead and just, even though this is relatively simple, let's go ahead and run through an example. All right, so we're just going to do a single example because the only difference between a population mean and a sample mean is what kind of data, right? So when you're going to use which one, and the real difference is just notation, right? Whether you use mu or you use x bar. As far as the calculation goes, it's absolutely the same. So the only thing that you would really be doing is what we did in, I believe it was chapter 1, right, where we're looking at, is this a statement about is this a parameter, right? Did I get information from the entire population, and that is what my measure is based off? If so, it is a parameter. You would want to use those population measures. If not, you'd want to use a sample. But for the same data set, you could define it as either, and the calculation for that mean is going to be the same. Alright, so all of that being said, just so we're absolutely clear, I'm going to say calculate a sample mean. And again, as an arithmetic mean, it's going to be calculated the same way. Right? So when we are calculating our sample mean, right, what we're going to do, we're going to just take this very slowly. Right, we just take all of our data, add it all up. So 19 plus 23, 23, 26, 29, 31, 31, 35, 10, 17. Right, and then we're going to divide by the total number of observations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so we have 9 observations, so you condense that down. Once we add that all up, just punching it into our calculator, we should get 1234 divided by 9. And so once we finish that off, taking it to 3 decimal places, we're going to get 137.111. And that's the answer, right? So that is an arithmetic mean. We're probably at least somewhat used to these. One thing I will mention, just now that this is the first time we're really going to be doing stuff with rounding, I will say this, alright, sometimes things change. I'm a little wishy-washy on these, but if you take it to the 3rd decimal place, that's always going to be good. Right, most of the time that's what I'm going to ask for. There are going to be some occasions where I don't. So say for instance we're looking at currency, money, the price of something. I'm not going to ask you to take something like that out to the 3rd decimal place, because that doesn't really make sense, right? We don't take currency out to the 3rd decimal place. But most of the time I try to specify what I want, and if not, you can never go wrong taking it out to the 3rd place. Right, but that is our first type of mean. All right, let's move on to our next one, the weighted mean. All right, so the weighted mean, the idea behind this is that we can, not every observation has to be counted equally. Right, so when we are looking at the arithmetic mean, each observation is counted the same. Sometimes we don't want that, right? And so we want a weighted mean. All right, so this is the formula for our weighted mean. All right, we got the sum of wi times xi. So in this instance, wi is the ith, or I guess really a better way of phrasing that is it is the weight of the ith observation. Alright, so I'm going to be using that OBS a lot, so I might as well define that. So it's the weight, so how much does the W2 is the amount that the second observation of this variable matters, like how important is it? Alright, xi, we really probably already know this is the ith observation of our random variable x, and that's really all the new stuff that we have. Right? So these get used quite a lot, especially by folks like me, because for probably a lot of your classes, I would hazard a guess to say a majority, but I don't know that for sure. But certainly my class, your final grade is calculated with a weighted average, right, or weighted mean. So the way this works is that you would have kind of weights to these different things. So let's think about our grade in here, or your grade rather. I don't actually get a grade. right? That first test is 25%, the second test is 25%. Your final exam is worth 30%, and your homework assignments are worth 20%. Right, so here, and let's erase that off. Alright, so let's say, ooh, that was bad slant. Alright. I've actually got a thing on here that will let me draw straight lines. I should just use that. Alright. Alright, so let's say, so this is us, this is my class, alright, so we've got our assignments, just kind of labeling things, and then we've got the weights that have been assigned to each. Alright, so now all we need is our grades, alright, so let's say that, I did these in a slightly wonky order, let's say first test we didn't do too good, we got a 51. Second test, we made a marked improvement, got a 78. And then on the final, we really went after it, got an 86. And on the homework, had a pretty solid 83. Alright, so how do we go about calculating this? Alright, well, we've got our weighted mean, alright, that's equal to the sum of our W's, right? The sum of our W times our XI's, right? Well, here, the grade, that's our X, so everything down here is our XI. So these are our XI's, and the weights, pretty conveniently labeled, right? Those are the weights, those are our W's. Alright, so for each pairing, right, we would say weight 1 times x1, or grade 1. So 25% times 51. Right, then we would just go down the list. Right, test 2, that's second grade. So 25%. 25% times 78. Alright, and so on and so forth. Alright, we would then add on our 30% for 86, and then tack on our 20% plus 83. Alright, now, this gets a little complicated here just because we used up a lot of space. Alright, that is just our numerator. Alright, our denominator is going to be, actually, you know what, let's just, y'all have got that graph down, we're just gonna clean this up a little bit, that's getting way too messy. Alright, I'm just gonna do WM, that's our weighted mean. Alright, so once again, and I'll do these, so 25% times 51 plus 25% times 78 plus 30% times 86, and then finally 20% times 83. Right, so that's our sum of our xi times our yi. In the denominator, we're going to do our the sum of our wi, so 25% plus 25% plus 30% plus 20%. Right, so that is going to come down to should be 7,465% divided by 100%. right, those percents are gonna, hopefully, just punch myself in the microphone, right? Those percentages are going to come off anyway, so you don't even need to put those in when you're doing the calculation, right? So if you're punching it into your calculator, some calculators have a percentage button. Those can mess you up sometimes, so you don't have to put it in there, right? But there we have, right? So our weighted mean, or in this case, our final average, is a 74.65 or a 75 in this class. All right, so that is a weighted mean. All right, one of the nice things about a weighted mean is that your weights don't actually have to add up to anything in particular, right? A lot of times, especially with things like grades and other things like that, they're going to add up to kind of 1 or 100, right? And that's not that doesn't have to be the case, right? Case in point, grade point averages. Those weights, the weights are a 4 for an A, 3 for a B, so on and so forth. Those don't add up to anything in particular. This means, all right, this also means that let's say we, all right, have those same grades, but we haven't had the final, right? And we're getting antsy, we're wondering, how much do I need to study, right? Because if I'm gonna ace this, I don't want to study, right? So we don't have our final, but we can still get an idea of what our grade is. All right. So we would just set up our weighted mean calculation as normal, right? And we just would not include that final exam. All right. So we'd have 25% for the first test that we got a 51 on. And we had 25% for test 2, which we got a 78 on. And then we don't have that final, but we do have our homework average. So we can pop all of that in. And then when we get to our denominator, right, we're only going to add up the weights that we use, right? So we don't have the information for that 20 or for that 30% yet. So we can't use it, right? So once we do that, we get 4,884 divided by 70%, right? Make that subtraction, and we get a weighted mean, or again, final average if we didn't include that final, all right, of 69.7, all right, telling you got a borderline C, all right, so that's going to round up to a C. But you might want to try to put in, a good effort to avoid going much farther down than that. All right, but again, that is our weighted mean. All right, so that means that we've got one last mean, and we'll go ahead and wrap this video up after we take a look at that. All right, but we've done our arithmetic mean, we've done our weighted mean, and now we're going to do our trimmed mean. All right, so the trimmed mean, I'm actually going to have a bit of a little definition for this. All right, the trimmed mean is an arithmetic mean with an equal amount of the highest and lowest values trimmed. All right, we're going to talk about why we might do this in a future video, but for now we'll just focus on how to do it. All right, so with our trimmed mean, what we need to do, all right, as it says, is we need to take the lowest and an equal amount of the highest and lowest values. All right, so when we are doing a trimmed mean, right, the first thing we have to do is we have to order the data. All right, the data I put up for the arithmetic mean was in order. It didn't have to be for that. It doesn't. Your data does not have to be in order for an arithmetic mean or a weighted mean. But it does have to be in order at a certain point for the trend mean. So once we get some data, we'll put that in order. All right. The next thing that you have to do is find out like how much to trim. All right. Third, all right, trim that data. All right. Fourth, calculate the mean. All right, so it probably doesn't really mean a whole lot right now, but it'll make a little bit more sense when we go through an example. All right, but that is what we do. All right, so just to save time, because I'm not going to write down a data set twice, once out of order and once in order. I'm going to write this data that we're going to use for example in order already. This is the same data that we used when we were looking at our arithmetic mean. Alright, so first things done, we ordered our data. Alright, and let's see, did I pick something? Yes, okay. So the way that these are going to be shown, right, is get something like find the 20% trimmed mean. Alright, so this 20%, alright, that's telling us how much, alright, we need to trim, or giving us, telling us how we find that out. Alright, so what we need to do is just 20% of all of these values, right, we need to take that many off. Alright, so to do that, we need to find the sample size. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, same as before, luckily, because we're using the same data set. So what is 20% of 9? Alright, well, we just need to do 9 times 0.2. That is going to give us, I believe, what is that going to give us? I should have written that down. 1.8, I would imagine. But I'm just going to double check. Yes, alright. So 1.8. Alright, so now here is something important, and this is something that's going to happen quite a few times. Alright, we cannot take 1.8 values off out of these numbers. Right, we can't take 80% of a number. Right, so we are going to round up. Right, we will always round up. Right, and we need to take 2 values. All right, actually, let me do that in a different color. All right, so we're gonna round up to 2 and take the 2 highest and 2 lowest values. Alright, so ultimately we will be taking off 4 values in total. We're going to be taking off 4 of these because we're going to take 2 off of both sides because we got that 1.8, so we rounded up. Yeah, we'll just keep it with this. Alright, so we need to trim the 2 highest, 2 lowest. Alright, this is why we need to have this in order so we know which ones are the highest and which ones are the lowest. Alright, but we're just going to trim those off. Alright, and then we're going to just calculate, right, an arithmetic mean, essentially, right, with what's left. Alright, so this is an arithmetic mean. Right, we're just modifying how we do that. Right, so instead of just taking everything, we are chopping off some of these values. Right, we're keeping some of them, and that looks like a mess. I'm gonna write that out a little bit better. Also, I don't know how easy that blue is going to be to see. You're gonna have to get back to me on that and see. Tell me which one of these colors are actually good. All right, so let's label it as the 20% trimmed mean. All right, if you use X bar, I wouldn't. Well, because everything y'all are doing is on the computer, so I'm not going to see. It's very unlikely I'll see what you write. But if you were to write that, I wouldn't be. I don't think anybody would be terribly upset about that. All right. So again, that 20% trimmed mean. All right, we're just trimming 20% of the highest and lowest values. And then what's remaining, we're just doing an arithmetic mean for that. All right, and so here with our 20% trimmed mean, we would get a 28. All right, but that's it for our means. That's not it for our measures of central location. There are two more that we're going to talk about, as well as looking at some comparisons for all of the different ones in our next video. All right, so I hope you found this informative, and I will see you guys in the next video.